So complete computation. So even they have to get the memory from the host memory and they need to compute it and return back to the host. What this next generation interconnect is going to do is, if you are an application programmer, you will write a multi-threaded application in order to scale your application into more number of CPUs and increase your compute power. Now, end of Moore's law comes and we are talking about accelerators. So can these accelerators be in the same coherent domain and you can half-load some of your applications threads to your accelerator? Yes, the new generation interconnects can half-load your computation, a complete thread into your accelerator, and the accelerator can be in a coherent domain to your CPUs. So what does this mean actually for an application programmer? So you have more number of CPUs, you are increasing your compute power with an accelerator, and that is in a coherent domain. So it's like you're really a co-proc. So what happens to the storage? So even if the accelerator needs to work on really the host memory, the new generation interconnects actually gives you an expansion memory where the accelerators can have a memory closely coupled with it, and still the host can look like expansion memory for the host. This is like you have a RAM inside your host, and still you can see the memory inside your accelerator as your expansion memory, expansion RAM. Through your NUMA paradigm, you can also access your memory closer to your accelerator. So for an application programmer, when you're writing a programmer, when you know that it's going to compute in CPU, you can allocate in your near memory. And if you want to, you know that the accelerator is going to act on it, you can allocate that in your remote memory. So we talk about computational storage, near memory processing. This is what we are trying to achieve. The accelerator having a memory, and you have an accelerator which can do compute, near memory compute. So if you want to scale your compute, you can expand your accelerators to a rack of accelerators and being still coherent with your host, and they're also coherent to each other. So you're expanding an infrastructure where you can increase your storage, distribute your compute. So what happens to the network? So earlier days, the packet used to arrive at host, and you to parse it, and you need to compute it and send the response back. So with this new kind of smart NICs, if an accelerator has a NIC, and it is a smart NIC, the packet can directly come onto the accelerator, it can parse it, it can store it, it can do computation, it can send the response back. So what is the infrastructure with this new interconnects is going to happen is, you have a host, you have a CPUs, you have a memory which is in memory, and you have an accelerators, a rack of accelerators which are coherent to each other and also with the host, and you have a NICs distributed across this NICs. So these kind of interconnects gives you a storage, compute, and network in a different paradigm, and the next generation data centers, you will see such interconnects accelerating your works. Thank you. Any questions?
It's just your opinion, no one's going to argue.
So, hello all. So today we are going to talk about the Kata containers, which brings best of both the worlds like VMs and container. Now, the containers are lightweight in nature because they share the same host kernel. But this brings some security vulnerabilities. Consider that there is some security issue in one of the container and it is affecting the host kernel or host. It means that all the containers will get impacted. One of the examples I can take is of the dirty cow attack, where cow stands for copy on write. So when you create a child process, the child shares the page table with the parent, and once the child process writes the data onto the particular page, only then the private copy of the page gets created. However, in the dirty cow attack, the write happens before creating the private copy. It means you're writing on the main page. From the storage side, we can take a very simple example. Consider that there is a directory on the host, and I bind mount that directory inside the container as a read-only. But because of this dirty cow attack, you can actually write to that read-only mount points. Now, so how to avoid it? So one way to avoid it is that you need a better isolation. And the virtual machines are much better in providing the isolation compared to the containers. So we need a fastness of the container and the isolation of the virtual machine. And that's where Kata container comes. So in the Kata container, so let's take example of the Docker and the Kubernetes. So when you create a container in the Docker or the Kubernetes, what happens is that using the OCI specification, the request is sent to the container runtime, which is by default in Docker is runc. And then it is the container runtime which do all the container management, like the creation of the container, deletion of the container, and so on. Now what happens in the Kata container is that there is a new runtime which is introduced, which is called as Kata runtime. So from the Kubernetes and Docker side, you still use the same commands to create a container like docker run or kubectl create. And those commands reaches to the Kata runtime. And what Kata runtime will do is, instead of creating a container, it will spawn a virtual machine. And this virtual machine is lightweight in nature. It is having a very minimal guest kernel. So it boots up very fast, right? And the container runs inside this virtual machine. So in this way, you are having the isolation of the virtual machine because your container is actually running inside the virtual machine. And all the container related things like creation of the container, deletion, and all the container management remain same from the Dockers and the Kubernetes perspective. So this is at a high level how we can use the Kata container to bring best of both the worlds. Yeah, thank you.
Before PCIe, there was actually PCI, no E. And that came about because there was a lot of complexity in the bus world. Every company had their own bus. S-Bus for Sun, True 64 for DEC. DEC and Sun don't even exist, but back then they were huge players in the computer market.
No.
Intel had ISA, Apple had NuBus, IBM had MCA. I was at a startup doing early pre-standard fiber channel. This was a nightmare. We had to build a different adapter for every computer vendor's bus. Then Intel and Sun and DEC, they got together and they pushed through a standardized bus across all computer platforms called PCI that then became PCIe and then Gen 2, Gen 3, Gen 4, soon Gen 5. So life was good. Except on the network side, because on the network side, every computer company had their own network. IBM had Token Ring, DEC had FDDI. There was also GigaNet, something that Dell pushed. There was Fiber Channel, and we had complexity again. If you wanted to deal with a certain storage or a certain computer vendor, you had to deal with the I/O interface they had. But luckily, history repeated itself, and we got Ethernet. And life was good again, except in the HPC world. In HPC, again, everybody building supercomputers, whether it was Cray or all the companies thinking machines that didn't exist. I guess Cray doesn't exist anymore, like after last week. Anyway, they all had their own proprietary interconnect for HPC. And then along came Intel pushing something called NGIO, and HP and IBM pushing something called FutureIO. I guess Sun was working on NGIO too. They finally got together and formed an agreement between FutureIO and NGIO, and they had InfiniBand. And life was good. History repeated itself again. Until now. Now we have CCIX, we have Gen Z, we have CAPI, we have NVLink, and now Intel brings out CLX. Everything's complex again, and a lot more expensive to support them all because ASICs are multi-million-dollar deals versus back in the startup days when you could do a card with very low speed buses for maybe $10,000, $15,000. So now it's a huge problem. And I hope history repeats itself again because we need everybody to build one new bus. Thank you.
The topic I chose for today's discussion was ignoring alerts and pathway to peril. So this issue actually happened in the field. So it was a customer production cluster that was down, and I look at it as a simple issue when ignored can result in serious cascading failures, which resulted in a whole cluster down situation. I'll just give you a 1-minute introduction on how Nutanix cluster as such works. CPU virtualization is done by the hypervisor, we all know, KVM, ESX, Hyper-V, and the storage virtualization is done by Nutanix proprietary solution. When you pack them together, what you get is a HCI solution, hyperconverged infrastructure. I look at this hyperconverged computing as a natural evolution of distributed computing, which has been around for decades. The moment I say distributed computing, you all know that we have a bunch of services which work together to provide the core functionality of the system, and they communicate via RPCs. So with that, I'll introduce a couple of services that we run on our Nutanix cluster, so that actually builds the case for the problem that actually happened in the field. Any enterprise class storage solution has to give you the ability to take snapshots and be able to replicate the data to a remote location. And as and when the snapshots expire, as per the policy set by the admin, you need to mark them for deletion. So we call this service DR service. And what do admins do? Admins create VMs on the cluster, and each of these VMs get a bunch of vDisks which they can operate on. So this explosive growth of this vDisk count is at the epicenter of the problem that we are seeing now. So as I said, the DR service only marks a vDisk for deletion. It doesn't delete it. So that work is actually punted to a service called curator. From the name itself, you can figure out that the service curates the cluster. It runs in the background from time to time, does things like ILM, move the cold data out to the cold tier. Likewise, any vDisks that are marked for deletion, just work on them and throw them out of the cluster. And likewise, if you have to apply any data transformations like compression, erasure coding, encryption, blah, 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 all such things, all these things happen in the background because they shouldn't come in the critical path of your read-write. So in this particular case, what the customer did, he configured the snapshot schedule with a 15-minute RPO. What does snapshotting as such involve? I'll just give you a one-liner on that. A virtual disk, when you say I'm taking a snapshot, all that happens is the current virtual disk is marked immutable, and you create a new vDisk which is parented to the immutable vDisk. So as and when reads happen, you walk up the parent chain to see whether the data is there, and as and when the writes happen, writes always happen to the leaf vDisk. So that's as simple as that. It's a constant time operation, doesn't matter how big your vDisk is, 10 terabyte, 1 terabyte, doesn't matter. So in this case, customer configured a snapshot schedule with a 15-minute RPO. Whereas the documented at that stage, at the time, this is a 2 year back story, so it was 60 minutes. He said, no, it's all working fine, what's the problem? Yeah, so obviously SEs don't push back because they want the next deal anyway. So it was all working fine for quite some time, and the admin went on vacation. And then the stand-in admin was kind of monitoring the cluster. And then one day users started to complain that their UVMs are not responsive. Then the obviously call came to the Nutanix support. Our guys, Nutanix support guys logged in, and they realized that alert manager has been complaining left, right, and center that this particular service called curator, it has been restarting often. All the services are configured with the RSS limits set. so that you don't actually, no service actually takes over the system. So these guys realize that, okay, curator is running into the RSS limits, so very simple workaround. Bump up the RS, double it. It didn't work. Simpler workaround, triple it. Didn't work. Even simplest solution, disable the RSS. And then what happened? System panicked. System ran into OOM. So effectively, that's when they escalated to my team. And then when we started realizing that curator shouldn't come in the data path, so obviously, why are the UVMs down? Then we realized that another service called even Pithos was down for the same reason. And then recovering from that point onwards, it was almost like a multi-day effort, and it was a pain for both customer as well as engineering. So what could have been done in 15 minutes or 20 minutes when the customer reacted to the first alert, it took for almost 10 man days kind of effort. So that's the story I wanted to share with you. So don't ignore alerts.
Early days of fiber channel, and yes, I really am that old. I used to lead the Fiber Channel Industry Association in Europe, and this was a technology that no one had really heard of in Europe, so we were doing a lot of evangelizing and going across various countries in Europe telling people about fiber channel. So I found myself in Munich in Germany at a conference not unlike this one, slightly bigger room, doing a presentation called "This is why fiber channel is going to change the world." So I get up on stage like this, lectern all set up, and I look up and there are two people in the room. There's one there and one right at the back. So like a true professional, I start my presentation, which is about 45 minutes. After about 20 minutes, the guy at the back got up and walked out. So, like a true professional, I continue. I get to the end of the presentation, and the poor guy still sat there, and I felt sorry for him. So I said to him, "Look, I want to apologize, and I hope it's not like this for the next presenter." He said, "I am the next presenter." May 21 and 22, those are the tentative dates. We'd love to see you all back here again. One thing you need to do, go back to your marketing teams and say, we need to sponsor this, okay? And get it in your calendars for next year, and we look forward to spending time with you again. Okay, let's do the draw.
So, Kanendu, you would want to...
Is that all of them? Any more last-minute feedback forms? There's one. Who do we have? Pramod from IBM. Big thanks to Mindtech and Kanendu for donating prizes this evening. Thank you. So this is portable SSD.
I don't see a name.
Anonymous wins the prize. Now go again. The suspense is killing me. Who do we have? We have Sunny Kumar from Red Hat. Oh, Sunny. Don't tell him. Come on, someone wants an SSD. Look at it.
Girish Gonda from Delhi EMC. No?
Oh. Okay. Deepak Vijay, Delhi MC? Yes. Thank you. So 3 quick USB sticks to give away. Let's do this quickly. Rob, come on. Let's make it work. Just shout stop, Rob.
Okay.
Yep. What have we got?
Paul.
We have Naveen Krishnamurthy from VMware. You see why you shouldn't leave? Stop.
Okay.
Karthik from Dell. Hang on. How many Karthiks are there in Dell? Come on. You could be anybody. Thank you. Okay, 2 more.
Yeah.
Let's go. Stop. I'm going to go for that one. It's anonymous.
Okay, another anonymous here.
Anonymous feedback is fine. We don't need your names, but it means you don't get a prize. Ashit Kumar from Huawei. Thanks. Last one. You can shout stop this time.
Okay.
This one?
Yeah.
Last one. Khalid Netap. Excellent. So thank you, folks. That concludes SDC 2019. Udain, we just want to say a couple of closing words.
Yeah. Thanks a lot to all the participants. Because of this, it has been possible. Again, thanking the sponsor companies, the speakers, the organizing committee, and we wish to see you again next year in May 2020 on 21st, 20 and 21st of May, right? So looking forward to see you again. Thank you and have a great weekend now. Bye. One quick point.
Hold on. Sorry. We have prizes to give out? Yes. We do. CalSoft, the Decode Trivia winners for today.
Yep, we had a smaller contest.
Okay. I think that's first one's Haris Iqbal for Dell EMC. And the second one goes to, photograph. And the second one goes to Saket Pusauka. Saket Pusauka. Veritas. Left?
Oh, okay.
Now what are you going to do?
You want to keep it?
No.
Maybe you can actually give it to Saket because he did deserve it.
Yeah. All right. Excellent.
Thank you.
Thank you, folks. Safe travel home.